Look at parallelograms in general and what characteristics are special about them and how we might use those characteristics to solve problems. The definition of a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So when you are told that something is a parallelogram, you are able to label the opposite pairs of sides as being parallel based off of that definition. Now, if the opposite sides are parallel, then you can use the properties of parallel lines to know things, for example, like this top angle and this angle here would add to 180 because if these lines are parallel, then those are same side interior angles and they would be supplementary. Same with these top two angles here and here, they would also be supplementary. So one of the properties for parallelograms is that consecutive angles are supplementary. And what consecutive means is just like, in a row. So the two across the top, the two across the side here, the two across the bottom, and then the two on that side would be supplementary to each other. Some other properties of parallelograms are that opposite sides are congruent. So this side and this side are equal to each other, and so are these opposite sides. Opposite angles will also be congruent. So this one and this one here are going to be equal to each other, and this one here and this one over here will also be equal to each other. Consecutive angle supplementary is what I was just mentioning, how these two, for example, will be adding to 180. And same as these two across the top, these two across the bottom. And another thing about them is that the diagonals of the parallelogram bisect each other. And it's hard to mark the diagonals with all of this other information, so I'm going to use the next picture for that. So here are the diagonals, which bisecting each other means that this one is split equally where it's crossed by the other. And this one is also split equally, meaning that where those diagonals are intersecting is the midpoint of each diagonal. Because parallelograms' opposite sides are parallel, the diagonals will also create transversals, and this will add more possibilities for problem solving with alternate interior angles. For example, this one here should match with this one should match with that one, this one here will match with this one down here, and then this one right here will match with this one over here. And so there's lots of things that you can end up setting equal. You can also use the fact that like these triangles in here, so like right here, you see this triangle, it's going to have triangle sum where the angles will add to 180, and that would help you to find this angle here at the middle. So lots of different problem solving things that could happen for parallelograms. Here are a couple of problems that we're going to work out related to parallelograms. If ABCD is a parallelogram, AD is 14 and EC is 10, and the measure of ABC is 65. So A to B to C is this whole angle up here being 65 degrees. DAC, so D to A to C is right here, 70 degrees. And BDC, this one down here, 25 degrees. So those are the given pieces of information. We want to find BC. Well, BC is opposite from AD, and since opposite sides are congruent, that's going to be 14. AC is this diagonal here, and we know that EC is 10, and we also know that in a parallelogram, the diagonals bisect each other. And that means that this portion up here will also be 10. DAB is this whole angle up at the top. And so since this whole angle over here, let me do some highlighting. Since this whole angle is 65, and we're looking for this whole angle here, we know that those are consecutive angles and that they should add to 180 degrees. So these two should add to 180, and we already have one that is 65. So 180 minus 65 gives us 115. So this angle over here is going to be 115. That's angle DAB. Angle ABD is next. So A to B to D, that's this top piece of this angle here. And it will be 25 because of alternate interior angles being congruent. Those two angles are going to match. Next is ACD. A to C to D is this one down here. We've already found that 115 is this whole angle up at the top. And we know that part of it is 70. So if we subtract 70, we get 45 for this remaining part at the top. That angle is congruent to this one down here that we're trying to find. So angle ACD is 45 degrees. And then the last one in this sample, ADB, A to D to B is this one right here. And let me think about, okay, so if 65 is this whole angle and the top part is 25, then we get 40 for this bottom portion. And then this bottom part here is alternate interior angles with this one here, so this one will also be 40. So that's how we can use the properties of parallelograms to solve when they give us some given measurements. Here is a sample problem where they've given us some algebra expressions. So we have to look at where the expressions are. These are consecutive angles, and we know that consecutive angles are supplementary. If they had labeled opposite angles, I would set the expressions equal. Since they labeled consecutive angles, I need to add these angles together and set them equal to 180 degrees. So we're going to combine like terms. And then we're going to solve. So to solve, I'm going to start by adding the 30, giving us 210 on the right, and then dividing by 15. That gives us an x value of 14. In this question, they want us to find the measure of angle BAD. So they're wanting this angle up here at the top. So we have to plug in the 14 for x. This gives us 117. So the measure of angle BAD is 117 degrees. Let's look again at the properties of parallelograms. If you have a parallelogram, then your opposite sides are going to be parallel and congruent to each other. If you have a parallelogram, the opposite angles will be congruent. The consecutive angles will be supplementary, and the diagonals will bisect each other. There are some ways to prove that you have a parallelogram, and so ways that you would know for sure that you have a parallelogram would be, the first one is, if you know that both pairs of opposite sides are parallelogram, then are parallel, then you have a parallelogram. If you know that both pairs of opposite sides are congruent, then you know you have a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. If one pair of opposite sides are both congruent and parallel, as you can see the two different markings for congruent and parallel here, then you know it's for sure a parallelogram. And then the fifth way to show that you have a parallelogram is to show that the diagonals are bisecting each other. If you have any of these, you're able to say for sure that you have a parallelogram. You're going to see some problems where they have images and they've given you some pieces of information, and you're going to need to figure out which of these reasons you have that you can use that information to show that you have a parallelogram. And there might be some where it's not going to be a parallelogram. So be careful as you're looking at those. Some of them you might find that there are two methods that you could possibly use. And as you look at the options in the multiple choice, There should only be one that actually works for those questions.